Until today, we could only observe asteroids moving in space. We could make predictions about their path and speed, and if an asteroid was approaching Earth at a high speed, the most we could do was estimate when and where it might collide with our planet. However, we had no power to control these events. But now, for the first time in human history, a mechanism has been developed to protect Earth from asteroids, and NASA conducted a live experiment that was witnessed by people all over the world. Around 650 million years ago, a massive asteroid, similar in size to Mount Everest, crashed into our planet. This asteroid, covering an area of 10 kilometers, caused significant changes to the Earth's surface. It was such a catastrophic event that it led to the extinction of the dinosaurs. But now, humans have developed technology to detect asteroids before they reach Earth. As time goes on, this technology is improving, allowing us to spot asteroids from much farther away. NASA has compiled a list of 26,115 asteroids that will come close to Earth. Among them, 16,420 are smaller than 100 meters, 8,807 are about 1 kilometer in size, and 888 are even larger than 1 kilometer. While there are no asteroids directly heading for Earth at the moment, it is possible that in the future, an asteroid might change its course and collide with our planet. If a 1-kilometer asteroid were to collide, it would release energy equivalent to that of 1,000 nuclear bombs. The destruction caused by such an impact is almost unimaginable. On our planet, we can handle destruction caused by various things, but dealing with asteroids has seemed impossible. However, NASA has made progress and conducted an experiment to tackle asteroids. They have developed a planetary defense system known as the kinetic impactor technique. This technique allows us to change the path of asteroids heading towards Earth. But how does it work? In outer space, away from Earth, there is no gravity or atmospheric pressure, so objects encounter no resistance in their path and can stay in motion indefinitely. If an object is moving at a speed of 10 kilometers per hour, it will continue moving at that speed forever until something comes in its path. This is possible because space is a vacuum and doesn't create any friction. Asteroids were formed millions of years ago as a result of collisions and have been traveling through space at high speeds since then. When they get closer to Earth, our planet's gravity attracts them, causing them to change their path. If an asteroid gets very close to Earth, it could collide with our planet, posing a threat. To address this, NASA scientists came up with an idea. They proposed that, before entering Earth's atmosphere, asteroids should be intentionally collided with a space probe at a specific angle. The collision would be large enough to alter the asteroid's path, diverting it away from our planet. According to the plan, NASA will deploy several space probes around the Earth. When they detect a large asteroid approaching our planet, they will direct one of the space probes to collide with the asteroid at a specific angle. To test this idea, NASA conducted an experiment called DART, which stands for Double Asteroid Redirection Test. On November 23, 2021, they launched the DART spacecraft using the SpaceX Falcon 9 rocket from the Vandenberg Space Force Base. Similar to other space probes, DART was equipped with thrusters, a camera system, and a radio link to send live images back to NASA. After a few hours, DART reached Earth's orbit. To test the collision, NASA needed a suitable asteroid. They found one called Dimorphos, which is located about 10 million kilometers away from our planet and is 170 meters long. Dimorphos orbits a planet 5 times its size, making it a small moon. While it's smaller than our moon, its weight is incredibly heavy, about 50 billion kilograms. On the other hand, the DART spacecraft is quite light, weighing only 579 kilograms. In comparison to Dimorphos, DART's mass is only about 0.00001%. When it comes to space physics, speed is more crucial than weight. NASA scientists performed complex calculations and found that if the DART spacecraft hit Dimorphos at a speed of 23,000 km per hour, it would change Dimorphos' direction by 1%. After completing all the necessary calculations, DART left Earth's orbit and headed towards Dimorphos, which was located around 10 million kilometers away. After several months, on September 26, 2022, when the collision was just a few hours away, NASA went live with footage from the cameras on DART. The live video showed DART traveling at 23,000 kilometers per hour, first passing the small planet around which Dimorphos was orbiting, and then colliding with the asteroid, which was as huge as 2 football fields. The last photo received from DART captured Dimorphos before NASA lost contact with the spacecraft forever. The collision was a happy news for all NASA scientists. It marked the first successful experiment of a planetary defense system in history. Experts expected that DART would break into pieces upon impact, while Dimorphos would veer off its original orbit and follow a new one. The results from this mission showed that Dimorphos lost about 1 million kilograms after the collision. Its orbit also shortened by 32 minutes, indicating a change in its direction. This experiment was conducted on a small asteroid, raising the question of whether the same technique would be effective against a larger 10-kilometer asteroid. Let's not forget that the Vredefort impact crater, the largest known impact crater, spans around 300 kilometers. Dealing with an asteroid that could create such a huge crater raises new challenges. What do you think? Could this technique be effective against a massive asteroid like that?